All right, and we're back. So all I've done is I've cleaned up the scene, and I've also expanded this a little bit because we may need a little bit of extra space here to type. Now, what we're going to be talking about is formatting, and string formatting is basically a way of feeding variables into a string. Okay, so let me show you exactly why we need to do this. So if I create my string and I just say that, okay, let me start with my name is, and then instead of giving it an actual name, I want to put a variable here, right? Now, let's say before the string we just had said that name equals, and then give it Bob. Okay. Now, how do we insert this over here? We can't just say name because we're inside of a string here, right? So if I just printed this, if I had to now print my string, that's not the result we were looking for, right? We wanted to actually interpret this as the actual variable. Okay. Now we could go and just end the string and then add this because we're adding another string. Okay. And then we get the result we want, but really this is just horrible. This is bad practice. You should not do this. Please do not do this, right? It's very hard to read. It also gets very confusing because this is a very simple example of it, but later on it can get much more confusing. Also, if you happen to feed it a float or something, now you have to actually convert it correctly or pad it. There's just so many things wrong with this, okay? So we're not going to do this. We're going to be a lot smarter about this. So what formatting allows us to do is essentially give it a special character inside of the string that represents where variables would be replaced. And then we run our formatting function and just feed it a list of variables, and then it'll put it in those places, right? Now we can either have them numbered places or named places, and I'll show you what I mean. So the special character that we're going to be using for this is curly braces. Okay, so just these curly brackets with a 0 inside of it. Okay, this means that it's going to basically replace this with whatever is the first thing in the list. That's why it's a 0. And we can feed it a longer list, and so we can have 1 and 2, and then, you know, it will go and replace this with whatever is third in the list because it's 0 based. Okay. So the function we're going to run is just called format. So after the string, because we're operating on the string, remember it's object-oriented programming, so on the string, we can apply this function. And how do we apply a function is after it, we just put dot and then format. Okay. Now here, what we're going to feed it is our list of arguments to replace in here. Okay. So if we just feed it our variable, which is already stored, okay, so we just feed it name, it's going to replace name with the word Bob, and then it's going to replace this with that. Okay. And so when I print, I now get my name is Bob. Okay. So very, very simple. Now we can also store other, a longer list than just one. So now we can say my name is something and I am something years old, right? But now we need to give it a list that is at least 2 in length, okay? And now you need to make sure that we put a 0 and a 1, not 2 zeros, because it will accept 2 zeros, which is another thing that sometimes we want to do, is insert the same variable multiple times within the string, okay? And that's also another reason why that previous method is terrible. You wouldn't want to have to end the string, then say plus name, and then again have another string, and then plus name, plus then the end of the string. It's just horrible. Whereas here we get to feed the variable in once, but actually have it replaced multiple times. And so if we do this, you see it actually does replace it in both spaces. But what we want to do is actually have a different variable here. So we just put 1, and now it's going to look in this list of arguments for whatever's next in the list. Okay. Now you don't have to feed it variables. You can also feed it a static amount. So you could just give it 30. But you see, I'm going to give it 30 as a string, which is a lot better. You can give it an integer, right? You can, and it will convert it, right? But if you give it a string, I mean, you're guaranteed to get the right result. So either way, I mean, you know, just be careful. If you are getting the wrong results, just be careful. It might be your typecasting. With integers, it's easy to convert, but with your floats, it gets a little bit more difficult, because how many points after the float do you keep, right? So we're going to be talking about that later, and a method to determine basically the size of the float. Okay, so this will work, or if we had it stored as another variable, then we could also just feed that in here and it'll work. Now, this is the sort of indexed method for formatting, and we use this very often. You'll especially when you're wanting to just do one like a quick replacement, or you know there's a list that you're already wanting to pass through. But sometimes, and especially in a case like this where we're specifically wanting to substitute a name or an age, something that actually has a label, then it's better to use keywords. The same as with dictionaries. That is why dictionaries exist, is we want to say that name is equal to Bob, age is 30, right? So instead of just feeding it these variables here, but then inside the string, you have to try and, you know, if you were reading this, especially if this was a very, very long string, and I mean, that can happen. You can have a multi-line string where you're substituting lots of variables, and now you have to read through and go, hang on, you know, okay, this is variable 5, so then it's the 6th one in the list, and you've got to go read through this long list of variables and go, okay, which is the 6th one? It becomes a lot more confusing. So if we get to that point, it's a lot better to use keywords. So instead of this 0, we can actually just feed it a keyword. Now, don't get confused. This here is not going to grab a variable name. Okay, this is actually creating its own internal variable. So within this format, it's expecting a keyword called name, right? And then whatever you put in that keyword, whatever you feed it, will be the result in here. So we cannot just, if I had to click apply here, it's going to complain, okay, because it can't find the keyword name, right? What I have to do is actually feed it the keyword. So I say name equals, so this name over here is referring to this one, right? So that we're saying this name, which should go here, is equal to what value, and then we can feed it whatever value we want. Now in this case, we happen to be giving it a variable that also has the same name, but we could give it whatever else we wanted. Okay, so you know, let's maybe just even call this one something else. You know, let's just call this my name, and then we'll put my name here, just to show you, just to clarify that just because there were too many uses of the same word, that it gets a little bit confusing. So our variable is called my name. We're feeding that into the value of name, which is a keyword inside here. Okay, so it's going to take this value, store it there, replace it here, then set it as name, which gets replaced here. All right, so I hope that's clear. So same thing with age, we would have to say age equals, okay? And here we could do something like my age, just for clarity. Just note that I don't normally do this. Like I normally just say name equals, and in here it'll be name equals name. That's totally fine, and you will see that come up a lot. But I'm just saying, I'm just putting this here so that I can be very clear to you which one is the variable and which one is the keyword, okay? And now if we click apply, same thing's going to happen, right? So we're substituting it with an actual word, which also means, I hope I'm not wrong here, but I believe that we can actually even mix up the order. So the order actually shouldn't matter because it knows where to find the keyword. Yes, so you see, you can even feed it age first. And it doesn't matter because it's not about the order of things. It knows that age is substituted for age, so you can actually feed this in a random order, okay? Not that you really want to, but sometimes it happens, okay? And I'll show you an example of when that would actually happen. Okay, so this is one of the methods, right? And what I want to show you is, you see how we're using keywords here. Now this reminds us a lot of dictionaries, like how we actually use our dictionaries. They have keywords and then a value for that keyword. So instead of having to do this weird name equals name, age equals age, and then, I mean, you know, with two variables, that's not too bad, but it can get out of hand. It can get really huge, okay? Instead of doing that, what we can do is actually unwrap a dictionary inside of here, okay? So this is kind of a more advanced method. If you're confused by this, just come back to it later when you do understand it, okay? But I'm going to show it because it's not too bad. Right, so assuming that we have a dictionary that we're wanting to then kind of maybe print, but in a nice way, so with, you know, a sentence like this, we're going to say, so my dict equals, and then, sorry, name, and then we give it Bob, or let's use a different name. Let's just use Amy. I think we've used that one before. So name, Amy, age 37 or whatever. Okay, so we would feed it these arguments. So sorry, now don't forget age needs to be a string, right? Our keyword over here, because it's not a variable, we're feeding it a string. Okay, so this is our dictionary. And obviously we could have a dictionary, like a list of dictionaries, because we would maybe want multiple people, and then we would loop through that list and then feed the dictionary into this format, okay? So instead of having to now go name equals name, age equals age, right? Because that is one way we could actually pull this dictionary into here, is we could say name equals, and then what we do is we refer to, remember, we refer to the dictionary, but then in square brackets, we give it the keyword that we're looking for. So we say, well, give me name, right? And in age, we would say my dict age, okay? And now when I print, it gives us the right result. So this is still doable. This is fine. But again, this is a lot of work. You're having to go, you know, basically passing each variable, especially when this dictionary could be a massive long list of details. We really don't want to have to do that, okay? So there is another way that we can do this. In fact, there's two more ways, so I'll show you both. So one way, I'll save the best for last, so I'll show you the sort of next best method, which is sometimes applicable, but then at the end I'm going to show you the ultimate way, right? So instead of giving it a variable like like this, where it's one specific variable at a time, I can actually feed it the dictionary itself and do this this kind of keyword call in here. So I can take the dictionary excuse me, I'm going to take the dictionary that I'm going to feed it and actually call the keyword in here. So it's name and age, okay? Now note that when you call it in here, it's a little bit strange, but you do not use the quotes over here as we would here, okay? It's just how it is, okay? It's just something you have to memorize, that when you feed it this way, because it's already a string, it doesn't expect you to feed it this as a string, you know, inside. So you don't have to put, you know, maybe double quotes in here just to get it to work, okay? So you just feed it this, but obviously the argument that this is now looking for, the keyword this is looking for, is a dictionary called dict, okay? So what we have to do is at least give it that in here. So we have to say dict equals, and then we feed it the variable, which is our dictionary over here, which is called mydict, okay? So I'm feeding that in here. It takes the dictionary in as a keyword, and then inside of these variables, it grabs the name from the dictionary and the age from the dictionary. So if I print, I get the result I want. Okay. So this is possible. You can feed it one variable and then just pull it apart inside. But even better than this, we're going to now go back to where we were looking for specifically just two keyword arguments, one called name, one called age. But this is only useful when our dictionary actually matches what we're looking for, right? And there cannot be any missing variables, or we can't, combine it with any other keywords, right? So what we do is essentially, remember how we typed it before, where we said name equals name, okay, or name equals my dict name, okay? There's a simple way to do this, which is if we feed it the actual dictionary itself, right, the entire dictionary. But before the word for the dictionary, if you put 2 stars, what this says is, I want you to unwrap this dictionary. So go through the dictionary, and every keyword becomes a variable, and then every value becomes the value that's stored in that variable, right? But it unwraps it just temporarily. So for the purposes of this function, it's as though we went and said, so before here, let's just remove all of this. It's as though we went through this dictionary and said name equals my dict name, and then age equals my dict age, and did that for every variable inside of here, created an actual variable instead of just a key and value pair, and then fed those into here, where we said name equals name and age equals age. Okay, so those are a lot of steps, but instead of that, just 2 stars does all of that for us. Okay, so now if I say apply, I get exactly the result that I want. Okay, so we're just here telling it to unwrap our dictionary, but it's because we're looking for name and name. If this was something else, so if this was looking for my name, then this would not work. Okay, so this method has its limitations, but if you're feeding it a whole dictionary that you're wanting to actually pull out, every key value pair you're wanting to represent in this string, and if the keywords in here match the keywords in here, then you can essentially just unwrap the dictionary and it will feed them in here. Okay, right. So, and the same goes for a list, by the way. If you had a list, so if you say my list equals, and then we just maybe let's just give it 2 numbers or whatever. Okay, now if we went back to our index method over here and then went and fed it my list, this would not work. Okay, now the reason for this is because we're feeding it. If you look at the argument, the error here, it's saying what we're doing is it's looking for a 1 here, but we've only fed it 1 argument. So this entire list, the entire list, is being fed into this first argument, and nothing is being found for the second argument. But if we unwrap our list, what it does is it essentially breaks this open and turns it into 2 variables, right? Now, unwrapping a list, you just put a single star. So dictionaries need 2 stars, and then lists need a single star. And now, so with that single star, it goes and actually puts the first variable in the list into the first variable here, and then the second one in the list into the second one here. Okay, so then we have the exact result we were after. Okay, so that's the main use of formatting, but I'm also going to show you how to do something else, which we will do quite often, which is using it for padding or sort of centering, and also controlling the size of your floats when they are printed. Okay, so let's just clear all of this, and in place of this 1 variable, I'm just going to put my var is, and then something, and then we're going to feed it a number. Okay, so let's just give it something, 56. Okay, so my var is 56, right? That's really simple. But now, what if we wanted to pad this number? Okay, because we may have a variable coming in here, and we're not sure what it's going to be. It could be 56, but it could be 1,000, or it could be 1. And what if we want that to be padded? So we want 0056. because we know we could be up to 4 digits and we prefer to represent it as 4 digits all the time. Okay. Now, obviously, keep in mind that you cannot pad just normal integers. You can only pad strings, because strings can store the actual value of 0, whereas an integer, if it has 0 before it, it will just, you know, it ignores that, right? So, actually, that's really weird. Why did it print 46? Okay, no idea what happened there. Anyway, don't pad your integers with zeros. That's all I'm saying. Right. So, well, how we can pad here is we can feed additional information into our variable over here. So remember, inside of our curly braces, this is saying this is a special character. So this is going to be replaced by whatever's in here. Okay. But we can feed it more information. So the first number in here is our index number, or it could be our we could say var, and then we would say var equals. Okay, so it doesn't matter, but the first number in here, the first argument, is basically which thing to grab from the list in this format. But if we put a colon, then we can give it additional kind of special functions over here to control how this number is then represented when replaced with 0. Okay, like, well, so when this 0 index is replaced by the first thing in the list. Okay, so the first, basically the first argument that we're going to give it is what to pad this with. Okay, so if we want to do 0 padding, we give it a 0, right? So, you know, because you want 0, 0, 5, 6. It is possible to pad with other things. I'll show you just now. We'll do an example of that just now. But, you know, normally you're going to do 0 padding. So it's 0 is the first thing. You're saying, okay, I wanted you to do padding with zeros. Okay. And then you give it the direction. Now, what I mean by the direction is, do we want it to be, let's say we padded it to 4 numbers, okay? And we've got our number 56. Well, do we represent that as 0056, okay, which is normal padding? Or do we do 0560, so in other words, it's center aligned, padded on either side with zeros, okay? Or do we do 5600, okay? Now, obviously with padding numbers, this is changing what the number actually is. This is padding it properly. So with numbers, it's an obvious choice. It's this one, okay? But with other strings, you may want it to be center aligned, okay? So for example, if we had to give, like, you know, some sort of heading, maybe when we do an error. So this is something we will do later on. I like to sort of have, you know, almost like a line, because you see how all of your printing gets all mixed up. You don't know whether this all printed in one function or whether it was printed one at a time. So I prefer to separate my, you know, printing. So I'll put something in, like all of these kind of equal signs, almost like I'm drawing a line. And then I want my heading, okay, well, maybe with a space. So I'll put a heading and then have that, right? But now I have to go through and count, like, how many are on this side, or maybe I should copy these and paste them on this side so that I know I've got exactly the same number equal on either side. And then if I change this to something, you know, longer or shorter, then now I have to, okay, yes, sure, it's equal on either side, but this may not be equal to the one at the bottom. It's very hard to control, okay? So instead of doing that, you would then want to just center align it, and then you just feed it. Instead of 4, you tell it, oh, I want to pad this to like 50 characters and center align it. But then instead of the 0, we give it an equal sign. And then it goes through and center aligns this with equal signs. Okay. So there's a lot that we can do with padding. In this case, we're just wanting to pad a number. So we want it to just be right aligned. In other words, it's going to appear on the right-hand side of all the 4 digits that we want. Okay. Then we tell it how many to pad to, so the number. So in this case, just 4. So we say, well, we want you to 0 pad right aligned to 4 digits. Okay. And now if I print, okay, so it's printed on this side. Let me just click here. There we are, printing on this side. okay, just so we can be consistent. So there we are, 0056. Okay. If I put this, so on most keyboards it's Shift 6, but yours may be a little bit different. But anyway, this upward arrow, that means center aligned. Okay, so that's exactly what we said there. And then the left arrow would be left aligned. Okay, so we can do that. If I center align, but let's say to 20, that's going to then give us a really big number over here, which we may use for maybe creating like some kind of serial like number or something where we store it in the middle, but we still want it padded. We can also give it something else. So instead of zeros, we can give it an equal sign, which is exactly what I said we would do over here, right? So then we're creating this sort of, it almost looks like a, some kind of heading or whatever, right? So there's a lot that we can do with this. Now, there's another thing that we can do. Let me just go back to 0 and let's do another, just normal. So, 4 padded. Actually, let's increase this a little bit. Let's go to 6. So 6 padded but right aligned, okay, which is normal number formatting. So we want to do that. But what if this was a float instead of an integer? Okay, but what if we had a really large float number? Okay, this will happen if we actually calculate a float number based on some kind of function, is we'll end up with a really massive number. Okay, now what this will normally do is you'll see it then it represents a certain amount of the number and then it stops. Okay, so it stopped after the 7854, so over there. Okay, now I think, as far as I know, there's a certain amount that it by default will represent, and then it kind of just cuts off, right? But we can control the size of how many how many fraction numbers it gives us, right? So here where we're controlling the number, where we give it 6, if we say 6.2, what that's saying is pad on the left hand side of the dot, the period, we're padding 6, but you also having 2 sort of float numbers afterwards, right? Now in this case it's trying to then automatically represent it with exponential format, right? But after this, we can put in a number to force it to be represented as a float. So you put an F. If you put an E, it would force it to print as exponential. So you just put an F and then say apply. And now we have 056.35. But you'll see that this in total takes up 6 characters, right? Because we're padding to 6, but 0.2 of them are the floating point fraction, basically. Okay, and then we're saying F as in specifically represented as a float, not an exponential format like this. Okay, so now we can then control exactly how many digits we will allow them to show. So there we go, there's exactly 5 characters after the period, and we could increase this as well and then say, okay, well now we want, now you see here when we had only 6, because this was taking up so much space, we have no zeros on this side, okay? And it's trying to set 6 as a sort of minimum, but if the point numbers go above 6, then it will just add nothing in the front end of it, okay? That's how padding works. So if we had to do padding, let's say we take all of this away and we do padding to 6, but we feed it a number that's bigger than 6 digits, it will just represent the whole number. It won't cut it off. But it's if we feed it a number that's less than 6 digits that it then pads it up to 6 digits. So it will be a minimum. Okay. So I hope that's all making sense. Lots of cool things we can do with all the formatting, and there are more things you can do with it, but I'm just going to show you because this is probably enough for now. And I rather want to just show you the things that we're going to actually use in this course. But you can always Google and find out. There's a few other little tricks and stuff that you can do with how to sort of pad numbers and do all sorts of weird things and different things. Like there's exponential and float, but there's others as well. Okay, so the final thing I want to end with when we're talking about strings is just the join function, and that's because it functions a little bit differently to how you'd expect it to work, and a lot of people get confused by it. Okay, so I figured it would be really good to show this because it's also very, very useful. We use it quite often, but it's very confusing. So again, I'm just going to create a string, and I'm going to print my string. But what we're going to put in here, so what if I have a list of items? Okay, so let me actually do that. Let me create my list, and then we just have some text and stuff, right? So we've got a list of items, and we want to join these all together because we've spoken previously about taking strings and splitting them, so we can split them by a certain character. For example, in this case, if this had been a sentence and we had just run the split function with no argument, then what it does is it splits it by the white space. Okay, so any gaps in this, so our string would have been some text and stuff like that, and then we would have fed it, said dot split, and just split it by nothing. Okay, and therefore it assumes that you mean white space, and it strips that and turns it into a list. Okay, now what if we want to rejoin this? What a lot of people try to do is, it seems intuitive in Python to feed it the list, say my list dot join. Okay, and this will not work. Okay, list objects do not have the word a function to join, right? So and this is why I'm specifically showing you this, because it's a little bit confusing. But what you're doing is actually the function join is saying I'm going to join the character that I'm operating on to the gaps in between the list that you give me. So instead of being my list.join, in other words, not a list function, it's a string function. And so we feed it, we create a character that we want to join the list with, and we run the join function on that character. Okay, so this is the correct way to type it, and I know it's a little bit confusing, but basically we're saying we feed it a string. It's a string function, so it operates on a string. So only if we've given it a string will this dot join read from this string object. Remember I explained why Python is object-oriented programming. Okay, so strings have a list of functions that can be applied to them. Well, join is a string function, right? But the argument that it wants is the list that you want to join using this character. Okay, and in this space, the character in this example, I've given it a space, a white space, to join this list. Okay, so now if I print, it's going to print that sentence, and it's joined by white spaces. I could go, and this is one of the main uses for this, is we're going to put a slash. So we're going to take a list of kind of the hierarchy of a folder structure and join it with a slash, right? So we will then join that all, or you could join it with whatever you want. I mean, you can even give it a whole crazy long list of characters, and it will join that between each one. Okay, so I just wanted to point this one out specifically because of how counterintuitive this seems. When you think about it, it makes sense because it's literally it's a string function. So you know it does make sense. But most people get confused by this, and immediately, intuitively, they want to type my list dot join and say join this list with slashes, and this is wrong. This does not work. This is how you write it. Okay, so that about wraps it up for strings. I know there's quite a lot of information to do with strings, but just know that they are very, very useful and very commonplace. We are going to use them a lot when working with our code because of their power to store a lot of different data types, storing numbers, floats, you know, whatever we want inside of these strings. So we need to know how to manipulate them and extract that data or combine things. So I'm sure that this will make a lot of sense later on when we start applying these functions to actual real-world examples. All right, so thank you very much, and I'll see you guys in the next lesson.